Okay, good morning.
Good morning, teacher.
Good morning, teacher.
How are you today?
We're fine, thank you.
Okay, today let's start with our new chapter, Chapter 9. Mathematical patterns. Now, in this chapter, we are learning about the sequence, the series. The series, it could be arithmetic and geometric, and also the sequence, it could be arithmetic and geometric. In this lesson today, we learn how can we write the mathematical pattern for a list of numbers. In this lesson, we have a list of numbers, but this list of numbers, it is ordered. It's not any numbers. I want to write it like grade 2 or grade 3. Any numbers, I guess I have to write. No, here there's a numbers. I will write them. These numbers are ordered. Sorry. And these numbers, I'm sorry, they are ordered. Now, here we know that there's something we call, what's happened? A sequence. Did you see what I wrote?
Yes.
Okay, so we are talking about the sequence. A sequence is an ordered list of numbers. Here we have a list of numbers, but this list of numbers, they are ordered. We name it as a sequence. Now, the sequence, it has a terms. The sequence, it has a terms in it. Wait, please, Yara. Okay. Now, so this sequence, we called it, sorry, it's a sequence, it's an ordered list of numbers. Each number in a sequence, we name it as a term. Each number, we name it as a term. We start with the first term, second term, third term, and so on. So each number in a sequence is a term. We name it as a term of the sequence. Now, how can we represent this term?
By n?
I'm sorry, but I want to accept Fiara. That's why I stopped talking. Now, by using what? By using a letter A, like it's mean a term, sub of 1. That's mean A sub of 1. That means this is the first term of a sequence. A sub 2, it is the second term of a sequence. A sub 3, it is the third term of a sequence, and so on. So, as you see here, we have a sequence. Here it's a sequence. Now, this sequence, it has a terms. How can I represent the term? By using a subscript, a subscript to a number that is the position that's related to the position of a term. A1, it's related to the first position. A2, the second position or the second term. Until nth term, it's related to, or an, a sub n, it's related to nth term of the sequence. Now, the two things here you have to note that it must start with A1. You cannot start with A3 or A4. You must start with the first term, and it cannot be negative. You cannot say A sub -1 or A sub 0 and so on. It must be positive integer numbers also. You cannot say A half or -half. So A positive integers and start with 1. Now also we are learning today, inshallah, how can we write the explicit formula and the recursive formula. Two formulas we learn to write it. Explicit formula and recursive formula. We will start with the explicit formula I give you the formula and you tell me the terms in the sequence. And also, I will give you the recursive formula and you give me the number of the terms in the sequence. And also, I will give you the opposite. I will give you the numbers, the ordered list of numbers, and you can tell me or can guess what will the explicit formula will be or what will the recursive formula will be. Let's start now with the explicit formula. What is the explicit formula? And what is the difference between it and the recursive formula? The explicit formula describes the nth term of a sequence using the number n. I mean, I told you before that the sequence, it's like A, n, A1, A2, A3, A4, until AN. The explicit formula, it tells me that there's a relation between the number in the sequence, like 1, and between the number and the nth term of a sequence, like 1, 2, 3, 4, 5, until n. Here there's a relation that the first term is 1. The second term, or a sub 2, is 2. A sub 3 is a 3. So the explicit formula, they describe the nth term using the number of the term. As an example, like if you have 1, 6, 9, 12, 15, and 18. For this sequence, it's a sequence. Why? Because it's an ordered list of numbers. Now, I want now to guess or to write the explicit formula that Miss Dima used to write this ordered number. By which formula? I will try to do like this. I will say this is the first term. This is the second term. This is the third term, the fourth term, and the fifth term.
They are all multiples of 3.
The sixth term. Now, look at here. It is number 1. Here it is 3, sorry. 1, 3, 2, 6, 3, 9. So, I will say that A sub n is. How can the 1 be 3 and how can the 2 here? I will now.
I'm multiplying it by 3.
The explicit formula describe the nth term of a sequence. Describe the 3 using the 1. Describe the 6 using the 2. It describes the nth term using the number n. Okay, so I can say like 3 times n. Why? Because if I multiply 1 with 3 here,
Will the answer be 3?
you will get 3. And if you multiply 2, the number of the term is 2. Multiply it by 3, you will get 6. And the number, as an example, if I ask you to find the fifth term using this formula, you say, I say that an is 3n. If we have a5, I will say 3 times 5, which is 15, as we say here. This one, we call it an explicit formula. I will repeat. Here, there's a relationship between the number of the term with the number in the sequence. Let's have problem number 1, generating a sequence using an explicit formula. A sequence has an explicit formula, an equal 3n minus 2. So here, in this problem, he told me that the explicit formula is 3n minus 2. And he asked me to write the first 10 terms of the sequence. How can I do? I will make a table like A1, A2, A3, A4, sorry, A5, A6, A7, A8, A9, and A10. Now let's start with A1. Look here. So A sub 1 is 3 times. What is n here?
1.
It is 1. So 3 times 1 minus 2. Then I will simplify. 3 times 1 is 3 minus 2 is 1. A 2 is 3 times 2 minus 2. 6 minus 2 is 4. So A1 is 1, A2 is 4. Let's go to A3 now. A3 is 3 times 3 minus 2. 9 minus 2 is 7. And
So let's just keep on adding 3.
yes. Now this, Susan, these things, they told me that adding 3 is not an explicit formula.
Yeah, it's recursive, but they'll
This is
never know we
recursive,
did
yeah.
that.
But yes, yeah. But here in the explicit formula, if I ask you to find A of 100, you can tell me. But later on, if we're talking about recursive, you need to find A sub 99 to find A of 100. A sub 100. So what did you say? It's true, but for the recursive formula. So for the explicit formula, if I asked you now as an example to find A of 9, you say it's 3 times 9 minus 2. 3 times 9 is 27, minus 2 is 25. So here, A of 9 is 25, and so on, just evaluating the numbers. This is for an explicit formula. Let's do number 12. Find the first 6 terms of each sequence. You have A of n is 2 raised to n minus 1. So I need to find, A1, A2, A3, A4, A5, and A6. A1 is 2 raised to the power 1 minus 1. 2 raised to the power 2 minus 1. I just evaluate with the number of the term instead of n. Substitute n with the number of term. A3 is 2. 3 minus 2 raised to 3 minus 1. Here it is 2 raised to 4 minus 1. 2 raised to 5 minus 1. And 2 raised to 6 minus 1. Then let's simplify. 2 raised to 1 is 2. Minus 1 is 1. 2 raised to 2 is 4. Minus 1 is 3. 2 raised to 3 is 8. Minus 1 is 7. 2 raised to 4 is 16. Minus 1, 15. 2 raised to 5 is 32. Minus 1, 31. And 2 raised to 6 is 64. Minus 1, 63. So here, by using this explicit formula, I can say that the sequence is 1, 3, 7, 15, 31, and 63. So in this problem here, he gave me the formula and I tell him what will be the sequence. This is now for the first formula. For the second one here, we will name it with the recursive formula. What is the recursive formula? The recursive formula here, I will compare each term with the previous one or with the term that's come before it. As an example, if you have 1, 5, 9, 13, 17, and so on. For this one here, the previous one or the previous formula, we compare the number of the term by the term. In the previous one, we can say the first term is 1 and the second term is 5. And the third term, how can I do with with number 3 to make it as 9? And how can we do with number 4 to make it as 13? And so on. That was, we call it recursive formula. Because we say that the recursive formula, I describe the nth term using the number n. I try to find a relation. I try to find a relation between the number of the term and the term. Here, no. In the recursive, I didn't find a relation between the number of the term and the term. I will find a relation between each term and the previous one or the term that come before it. This one we called it recursive formula. As an example, let's now try to find the recursive formula for this listed of number. How can I do? The previous one, I say A1 is 1, A2 is 5. So we tried here, we said, how can I do with number 1 to be as a 3? I multiply it by 3. And how can I do with so for the recursive, for the explicit, here we have 1, I multiply it by 3, I get to 3. For 2, I'll multiply it by 3, I get 6. For 3, I multiply it by 3 and get 9. This is we call the explicit. I try to find a relation between the number of the term and the term. But for the recursive, no. Recursive, I just compare the second one with the previous one. I say 5 multiplied by number give me 1, or 5 subtract a number give me 1. I will ask myself if I can add, if I can multiply, divide, or subtract. Here 5, or the difference between 1 and 5 is 4. The difference, I can say 5 plus 9 is also 4. 5 plus 4, sorry, is 9. 9, can I add 4 to it, give me 13? Yes. So 13, can I add 4 to it and give me 17? Yes. So I find the relation. The previous one, I multiply the number of the term by 3. Yes? Yes?
No.
Okay. Now, so here in the recursive formula, I have an ordered list of number. I want to check what is the relation between the second term and the previous one. Look at here, 1 plus 4 is 5, and 5 plus 4 is 9. So the formula, it will be A sub n is, I will not say n plus number. No, this is for the explicit formula. I will describe it with the previous one, like A sub n minus 1, with the term that comes before it. Then, as you see here, the first of my new term, which is 5, is the first term plus what? Plus 4. So I will add here 4. I will repeat. Look at the 17 here. This 17 is A of sub 5. So I will try to find a sub to sub 5 by what? As I told you, by using the previous term. So it will be a sub 4 plus 4. A sub 4 here is what? 13 plus 4 is 17. Who can tell me what will be the sixth term? Yes, Raghat? Raghat, are you here?
Yes, I'm still solving.
Yes, Raghat. How can you tell me, okay, can you tell me, sorry, please, what will be the sixth term? Raghat? Raghat, yes, please.
Yes, I'm doing it now.
Okay, tell me. Let's do it with with myself. Yeah. A5, A sub 5. Yes, Raghat.
A6 equals A6 minus 1, which is A sub 5, plus 4.
Plus 1.
Plus 4.
Plus 4, thank you. So what is A sub 5?
It is 17.
It is 70, thank you. Plus
4.
4, you will get
21.
21, thank you. These are 4. Now A sub 6. Okay.
Teacher,
Yes.
they make it A5, like they mean that is the number of the term. 5 is the number of the term.
Can you repeat?
Like A5, they mean about 5, that it is the number of the term.
Yes, the number of the term. And term. I told you before in the first lesson, in the beginning, sorry, of the lesson. I told you if you have a 5 sub 5, it's mean that this is the fifth term of a sequence. A sub 5, it's the fifth term. A sub 7, it is the seventh term of a sequence, and so on. So,
Teacher,
yes,
but can't we just add 4 to 17 and we will still get 21?
yes, that's what I did.
And do we have to write the things you wrote?
You mean the formula?
Yeah.
Yes. Well, you need to write if you want to find the recursive formula or to write the term. You need the formula. Look here. I want to continue. So now, if I want to write, or if I want to write is to find the numbers of the sequence, I need two things. I need an initial condition, which is A1. I need to write it to find it. And also I need the recursive formula. Every time if ask me to write a list of numbers, I need two things. I need the initial term from which will I start, and also I need the recursive formula. This recursive formula can help me, like this one as an example. It can help me to find the second term and the third term and the fourth term. Without an initial condition, I cannot.
The explicit formula.
No.
Like if it's multiplied by these.
Wait, pause. I will tell you the difference between. No, wait a minute, please. So for the recursive formula, I must need the initial formula, and also I need the formula. I need both of them, the initial and the formula, because if I know that A1 as an example is 133. So this is for A1. So A2 it will be A1 minus 3. What is A1? It's 133. Minus 3, it is 130. So the second term, it will be 130. What about now A3? A3 is A2 minus 3. A2 is 130. Minus 3 is 127. So every time, if I need to find any term, I must need the previous one. This is for the recursive formula. Now, what's the difference between them? For the explicit, no, for the explicit formula, if both of them, I will write it like this, A sub n, A sub n. But in the explicit formula, I say A sub n is equal to n plus 4 as an example. Between n, the number of the term, and difference or multiply or so on. So I just here to compare between the number of the term and the term. But in the recursive formula, I need to compare between the previous term plus 4. The compare between the term and its previous one. This is for the first one. The first thing. The second thing, if I told you find A of 100 as an example, it's very easy. I just substitute instead of n with 100 plus 4, and I say it is 104. So if I ask you to find any nth term of a sequence, it's very easy. Just evaluate with n with the number of term, which is 100. But in the recursive formula, no. If I want to find A of 100, I need to find A of, what is the number before 100? 99 plus 4. So if I need to find A of sub 100, I need to find A sub 99. I don't have A of sub 99. I go back to 98. I don't have back to 97 until I reached A of 1. If I reached A of 1, I will find A of 2, then 3, 4, 5. It's like building a block. If I put the first block, I can put another block for it. But I cannot block 100 from the sky. I need another blocks down from it. This is the second thing. The third thing, that here for the explicit formula, I didn't need an initial condition. Why? Because my formula here, it doesn't depend on the previous formula or on the initial formula. It depends only on the number of the term. But in the recursive formula, I need an initial condition. I must know from where I start. Okay, he told me that the second term is the first term plus 4. It's okay, but what will be with the first term? You have to tell me what is the first term, what is the initial condition, or you can omit with A1 and tell me the formula. If you give me the initial condition without formula, I cannot write the table or cannot fill the table. And if you give me the formula without the initial condition, also I cannot. You must give me two things, the initial condition and the formula. But in the explicit formula, I just need the formula to find the sequence. This will be the difference between the explicit and the recursive. Look at problem number 2. Here now, I want...
Can you go back a little?
Yes, Rose. Yes, Rose.
خلاص it's okay.
Now, In problem number 2, here I want now to write a recursive definition of a sequence. As I told you before, if I want to write a recursive definition, I need two things: an initial condition and a recursive formula. So here, I want now to find a definition. I will here the number of blocks in the
They
two
are adding 3.
sequence that follows the recursive formula. What is the recursive definition for the sequence? Here now, the first term is A1. Sorry. We have 3, 1, 3, 1, 2, 3, 4, 5, 6. So 6. Then just count the blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we have 6, we said 3, 1. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 1, 2, 3, 4, 5, 6, 6 plus 4 is 10, 15, 20, 21. So these are now the numbers. We have 1, 3, 6, 10, 15, and 21. Recursive, I just need, oh sorry, here I have to find the initial condition, which is 1. It is written. And then now I have all the terms. I need now to find the formula.
Teacher, if I don't have 1, it will be wrong.
Yeah, it's not wrong. I cannot find the formula. So now I need to find the recursive form, the recursive definition or recursive formula. It is a n. It will be a of n minus 1. I try to find the relation between the second term and the first term, and the third and the second, and so on. Let's see here. Let's try. 1 multiply by 3, give me 3. 3, I must multiply by the same number, the same condition. 3 times 3 is 9, so I cannot say multiply. I cannot.
Why you multiply it by the same?
You have to guess, yeah, Rose. You have to guess if can I multiply, if I divide, if I subtract. Okay? Here is an open exercises, open practices. Every question has a new idea. You have to practice. So if I multiply, I cannot. Let's now try to add. A plus 2. 3 plus, how can I make it 6 plus 3? 6 plus 4. 10 plus 5. Then 15 plus 6. I will get 21. Okay.
So it is a subscript n equals a subscript n minus 1 plus n.
Yes, Sausan, thank you. I will tell you now how.
I'm Ragad.
I'm Ragad. Okay, sorry, Ragad. So here now we have the previous term. Then look at here. Here we have the first term. The first term plus n. Look here, I write it. I say the first term plus 2, I will get the second term. Then the second term, which is 3, plus 3, I will get the third term. Then I say 6 plus 4, I will get the fourth term. So what did you notice from here? I noticed that the previous term plus the number of the term, I get the new one. Like here, 1. I want to find the second term. What is the meaning of the second term? It means it's 2. So the previous one plus 2, I get the second term. Let's find the fifth term. The fifth term is like this, I say. The fifth term is the fourth term plus what? 10 plus what? Give me 15.
Plus 1.
Plus 5.
Like, you have to put it like this now. I say that a of 5 is a of 4 plus 5. Now, I want now to rewrite it, but not what the numbers with n. So I say, if here is n, here it will be n. And here it will be n minus 1. So, it can write as a of n is equal to a of n minus 1 plus n. I know you are shocked, but
Teacher, what about the 4 and the 5?
all of them here. So because let's go to find as an example a3. I say a3 is a2, like this is the start. I'll say a3 is equal a2 plus or minus what? Let's see. a3 is 10 plus 4, I will get 6. So the second term, sorry.
Teacher, how 10 plus 4 becomes 6?
Here, I say the second term, which is 6. If I add it to 4, I will get 10. This is the third term, as you see in the pyramid here. So because of that, I go back to rewrite the formula. I say here, it's A3, I'm sorry.
But teacher, isn't the third term 6?
I know I'd say A2 with A3. I'm sorry. Here I say A3 with A2 plus what? So A3, it is 6, as you see here. The third term is 6. The second term is a 3. So I will ask myself, 3, how can I make with the 3 to be as 6? By adding what?
By adding the number of the term.
So, yes, so by adding a 3. Then this is the first step I said. Then I will try now to translate it, but with an nth term. I say here A3. And here I added 3. Since the 3 here is the same as 3 here, so I will write n here, and I will write a of n here. And as we said before, here we have to write the previous one. A of n, a, the previous term, plus n. Why plus n? Because look here, 3 plus 3 plus 4. I mean that before you go, I mean that I want to find the fifth term. Okay, I say 5 plus the previous term. The fourth term, 4 plus the previous term. The third term, 3 plus the previous term, and so on. Is it clear?
Yes.
Yes.
Okay, inshallah, tomorrow we will, when we continue, we will get more exercises. You will understand, inshallah, more and more. This is because it's the beginning. The second thing here, you have to know that later on it's not just multiply or add. You have to guess. Sometimes you have to think out of the box. Sometimes you add, sometimes you multiply, as we will say on got it later on. Sometimes you say to the power of 2, and so on.
But teacher, like what if it was adding in the recursive formula? What we will do in the formula, in the exact formula that it is an equal an minus 1?
Can you repeat?
Like if we are multiplying in the recursive definition, this one, what we will make in the formula?
It's like this. As an example, it is a n minus 1 multiplied by 2n as an example.
Okay.
Or multiplying by 2, and so on.
Thank you, teacher.
You are welcome. I know it could be not so clear as you guess, but because it's the beginning of a new chapter, inshallah, next lesson tomorrow, we have 2 lessons. Inshallah, we will continue our lesson and it will be more clearly for you. Thank you for listening.
Have a nice day.
Thank you.